Welcome everybody. My name is Cray Van Sickle, and with me are my colleagues, Mary Morgan, who's going to perhaps join us because of her unstable internet connection, and Mark Haubner. We are with Drawdown East End, whose mission is to advance local solutions to reverse global warming. And tonight we are co-sponsoring this special public meeting with Southampton Town's Sustainability Committee on the topic of advancing kelp farming on the East End. And we have with us some very special guests, Sean Barrett, Scott Bluedorn, and Dr. Chris Gobler. They'll be introduced in a moment by Mark. I just wanted to mention to those of us who are on the screen here that we are recording this, so it will be available after this live event at our website, drawdown.eastend.org, in a day or so. The website link is posted in the chat, and I also want to mention that two other things about the chat box is please post your questions if you have them directed at whomever it is that you'd like to answer in the chat box, and we'll review that and call on that when we have the question and answer period. And also the link to a petition that we are going to bring your attention to is also at the very top of the chat box. So with that, I just want to introduce Dieter from the Southampton Sustainability Committee to talk about his group and what their interest and involvement in this kelp effort is. So Dieter, I'm going to take it away.
Thank you, Craig. Thanks for your opening remarks. I'd like to first of all say that we are very happy to co-sponsor this meeting with Drawdown East. For that will give a big push to many people as to what is so important. How did we come to do the kelp thing? Kelp is something which was brought to my attention actually by Dar Riley, of many who you know, for she's eating this stuff. And I said, well, what the hell is all this all about? And then I started to look into it. And I must say I was surprised of kelp, which I knew from wonderful films from the California coast, what kelp is all being used for. And maybe you will be surprised to hear that is good in toothpaste, shampoos, salad dressings, puddings, cakes, dairy products, frozen foods, and even pharmaceuticals. It's rich in iron, fiber, magnesium, and vitamins. Well, so this is one hell of a product, I thought. And then I looked it up on the internet and I found out that there's commercial farming on this one. And as we always looking for products, mainly from nature, which helps us environmentally, and at the same time are a commercial product, where we decided to start a Zoom like tonight to inform everyone interested in kelp farming. And for that, we have some experts on here, which I like to introduce now. And in that order, they will then speak. The first one is one which many of you know very well, which is Professor Chris Gobler from Stony Brook. He is, as I call him, Mr. Water. He knows all about what happens in the water and with the water and around water. And he will tell us what kelp does and how positive that is as a product. The next speaker in order will be Sean Barrett. And Sean, well, he actually does it. He's a farmer. He farms kelp and does things with it. You might know him with his company, Dock to Dish. So that's the same guy. And so he might bring kelp to your dish. And last but not least, we have as a speaker Scott. Scott is from is a member, Scott Bludon is a member of the East Hampton Sustainability and Energy Committee, and I've known him from that for a few years. And he is, I would say, the activist, pushing for kelp all along. Now, before we go now into the program, I'd like to say a special thank you to Jim Hewing and Mary Morgan, who have put this program together painstakingly, trying to get everyone on board. And without further ado, I'd like to pass it on to you, Chris. Please give it a go.
Can I jump in with a question first to get you started, Dr. Gobler?
Sure.
Okay. I would like to say that our goal tonight is threefold: to discuss the benefits of kelp farming for the East End, number one; number two, to encourage you all to sign the petition to legalize kelp farming in New York State. The link is in the chat box. And to introduce the idea of a local blue-green economy, with the East End taking leadership for a healthy, thriving Peconic Bay bioregion. We can do this by investing in, supporting, and celebrating local businesses that use regenerative practices, that renew our natural resources, those which are not extractive or polluting. Kelp farming is a restorative business and is one of several ocean solutions to reverse global warming identified by Project Drawdown. It is a nature-based solution that can move us into a thriving blue-green economy. Dr. Gobler is the chair of Coastal Ecology and Conservation and professor in the School of Marine and Atmospheric Sciences, Stony Brook University. He has been working with seaweeds and their ecological benefits on Long Island for 15 years. His lab group began growing kelp on Long Island in 2018, and in 2019, they opened New York's first kelp hatchery. Dr. Gobler, can you tell us about your work and your focus on kelp as a climate solution that has quantifiable impacts and benefits for the health of our bays?
I sure will. So thank you for that introduction. And it's a pleasure to be speaking with everyone. And it's very exciting to see actually the interest in this topic, and exciting to be speaking with you all. So just to jump right into it, I'm going to try to cover a little bit just background here, since I'm leading things off, and then really focus on environmental benefits from kelp, including combating climate change. So just jumping right into things here. If you didn't know, seaweeds are farmed around the world, but if we come to the United States, the most commonly farmed seaweed is kelp, sugar kelp. This is known as scientifically, genus and species, Latissima saccharina. And, and globally, actually, seaweeds are, there's billions of dollars made in farming seaweeds, primarily in Asia. But it's an emerging market in the United States, both in the Northeast, but also on the West Coast. New York is a little bit behind the curve, but I'm confident, like with many environmental things in New York, that we can soon get to the head of the curve. Beyond the fact that it's already farmed in the Northeast, importantly, kelp is actually indigenous to our local waters. So this is a picture of kelp taken from Long Island Sound. And I'll soon show you our kelp hatchery, and we run that hatchery using and spawning indigenous kelp from Long Island waters. And Sean may cover this, but the nice thing about kelp and the way we're really considering it is the way that it can be integrated with ongoing aquaculture activities. In New York, the biggest source of aquaculture in New York is oysters, and there's more than 36 oyster farms across New York. And the nice thing about kelp is that it can be integrated into oyster farms vertically. And so that is to say that an oyster farmer wouldn't need more acreage to support farming kelp. It can be put right on the lines that have the current shellfish cages, be they surface or bottom. And the other important thing is that kelp adds, it's the opposite growing season of oysters, And what it does for, I'm going to speak to the environmental benefits, and Sean may touch on this as well, but I think it's worth just stating that it really, people talk about sustainability. This is going to contribute to the sustainability and the resilience of aquaculture. Like I said, there's about 36 oyster farms across New York State. And really, when it comes to marine aquaculture, oysters are the only game in town. And we learned on the eastern end of Long Island in the middle and early 20th century, if you're a farmer, approaching farming with a single crop is well, I was going to say a fool's endeavor, but it is not the way to farm resiliently, because it leaves you vulnerable to disease of your crop, to turn down in the economy. And frankly, this was acutely apparent during the 2020 COVID crisis. That is, COVID hit, and the biggest market for oysters were restaurants. Well, nobody was going to restaurants at the rate they had in the past during 2020. And frankly, a lot of oyster farmers, because that's what they farmed, found themselves in financial dire straits because they could not sell their product. And so the other nice thing beyond the environmental benefits is that this has the ability to make aquaculture, marine aquaculture, more sustainable in New York State, is providing a second crop that complements the growing season of oysters. So we did start the first New York State DEC permitted kelp hatchery in New York State in 2019. This is at the Stony Brook Southampton Marine Sciences Center. And what we do is we spawn reproductive blades of kelp onto what we call seed strings, which are shown here. And so you can see the strings. Well, essentially, these are PVC pipes with wound with string. We have the kelp spawn within the tanks. We add that spawn to them, and over a short period of time, you see them go from the white to the brown, which means that this spawn has been successful and the kelp is starting to grow. And I should say, as I showed in a slide 2 prior, we had this success because of a great collaboration with the organization Green Wave. They have been pioneers in promoting kelp aquaculture all throughout the Northeast. And frankly, we got our start because the head of that organization, Brendan Smith, came out to us and talked to us about kelp, frankly, in 2018. We struck a collaboration since then. We got a grant together from the United States Department of Agriculture, and that really spawned what we're doing here. So really, that our establishment of this kelp hatchery was with the great assist from Green Wave, and we've done it successfully for 2 seasons now, producing about 50 spools of kelp. When we have plenty of room to grow in this, and each spool can be a 100 to 200 foot line of kelp. During the past 3 seasons, we've worked on more than 10 oyster farms all across New York State. They're color-coded here. You can see in the red in 2019, we were on East End Oyster on Long Island Sound, and 2 sites in the South Shore, in Great South Bay, Lucky 13, and in Moriches Bay, the Great Gun Shellfish Farm, Oyster Farm. And we've been there those 2 we've been out on every single year. So it's harder to see the 2020 sites there, but we've been there 2019, 2020, and 2021. In 2020, we also had additional sites at Widow's Hole Oyster Farm in Greenport, and also out on Fisher's Island at the Fisher's Island Oyster Farm. And this year, in exciting news, we have support from Suffolk County to expand the work we're doing. And we're working on 5 different oyster farms across the Peconic Estuary. All of these farms are involved in the Suffolk County aquaculture lease program, so they're already oyster farmers there, and this year we're growing kelp on their farms. So just to show very quickly, I'm not going to show a lot of data in this talk, but just to give you a sense of some of the yields. This is our results from 2020 across multiple sites. In some cases, also showing multiple seed strings. But importantly, and I'd mentioned that kelp was the opposite growing season of the oysters. And here you can see that in action. We put the kelp out, generally the lines in December. And you can see they grow ever so slightly until the water begins to warm up, and then they really take off in spring. And what you'll see is none of these lines go into July. So we're harvesting these kelp in either May or June, depending on the year and the temperatures. But what you can see is we're getting some really amazing yields. In some cases, up to 9 pounds of kelp in just 1 foot of line. And again, we're putting out on each farm, on average, we're usually putting out at least 3 lines that are 100 feet. So that's close to 1,000 pounds. And you can see that is generated literally, the growth takes off in March. So there's almost nothing on the lines in March. But by the time it comes to harvest, just 2 months later, again, up to 1,000 pounds per farm with just 3 lines. These kelp blades are incredibly long. Here's Mike Dole, and I should have mentioned, I failed to mention, Mike Dole is really he's the head of restorative aquaculture in my lab group. And he, frankly, were it not for Mike, I would not be here talking about this today. He was an oyster farmer out in Montauk for 10 years. He's been working with me for the past 4 years. And within the first year, he brought Bren Smith to Southampton to start this conversation about kelp. So I give all the credit to Mike for his hard work. And you can see here, it's not these blades are we're not just getting great weights, but you can see amazing lengths on these blades, more than 10 feet in some cases. And I will just say that when we began this effort, prior to our work, just 3 years ago, and frankly, when we started, we had some people say to us, you're not going to have any success. You are targeting shallow estuaries like Moriches Bay, where the mean water depth is only 4 feet. There's no way you're going to get the kelp to grow. And because the kelp's going to drag in the sediment and it's going to get fouled. Well, anyway, the bottom line is, through this project, we've been able to prove kelp grows wonderfully in shallow water. And in fact, we're getting better yields in shallow water than we are in deep water. So again, before this, everyone assumed that it had to be done in deeper waters like Long Island Sound and the deeper part of the Peconics. Our best site has been in Moriches Bay, where at low tide, we might just have a foot of water. And the kelp is just dragging through the sediment with the currents, and it loves it. It's growing very well. Okay, so to talk about a little bit about what the benefits are of these of the kelp. These are photosynthetic organisms, so as you all know, they're taking up carbon dioxide, which is obviously a big focus of drawdown and drawing down carbon. I'm also very interested in the fact they take up a lot of nitrogen. They're a sponge for nitrogen. So you're getting both the carbon and the nitrogen. And we know their waste product is oxygen. So they're oxygenating our waters. And I'm going to just show you a little bit about what maybe they can be doing against harmful algal blooms. To go through just a little bit of data. Do they take up carbon? Well, they sure do. And so here you can see we're getting, they contain about 25% of their dry weight is carbon. You can see that here. No difference across sites. They all are quite rich in carbon, maybe slightly more in the Long Island Sound site. But they also take up plenty of nitrogen. And here we're showing the amount of nitrogen milligrams per milligram dry weight. In this case, it's a little bit closer to 3%. But here we're seeing differences. And this was interesting to me. We're getting more nitrogen, richer nitrogen content in the shallower sites. And these are sites that, we have to hone in on where these sites are precisely. But the sites where Moriches Bay are, the sites in Great Isles Bay and Moriches Bay are shallow sites closer to land. The Long Island Sound place, Long Island Sound is the 3rd largest estuary in the United States, so we don't want to make generalizations, but this is really an almost essential and eastern part of Long Island Sound where the nitrogen levels are actually quite low. So the interesting trend here is that the regions with the highest nitrogen concentrations, the kelp are taking up actually more nitrogen. So, we, as everyone knows, I'm sure the people and the Sustainability Committee know as well, nitrogen's a big issue that we're fighting as well. And so these, not only is the kelp taking up nitrogen, but it takes up more in the regions that have excessive nitrogen. And I won't linger on this too long, but we have a technique for looking at where the nitrogen's coming from that they take up. It's looking at the isotopes and the ratio of the atomic weight of the isotopes of nitrogen in the kelp. We call it the del N15 signature. And here's these numbers. They may not tell you a lot, but they tell me a lot because we compare this to the nitrogen that we find in wastewater and the nitrogen that we find in fertilizer. And so if these kelp were using nitrogen just from fertilizer, they would have a value of -3 on this scale. If they're using mainly wastewater, they'd have a signature approaching 10 on this scale. So you can clearly see, not only are they taking up the nitrogen, but they're taking up nitrogen that originates from wastewater. Now let me be clear, this is atomic nitrogen, so this has nothing to do with any, don't think about like what wastewater is. It just tells you ultimately where the nitrogen came from in the very first place. And that is, it looks like it's coming from wastewater. So between this slide and this one, what I'm telling you is that when you put these kelp in locations that have an overload in your nitrogen from wastewater, and we know that's where our nitrogen mainly comes from, so this is not a surprise, they're able to take that nitrogen out of the water column. And, right now we're doing all of our work at really what I would call the experimental phase, right? We're growing, I told you, 100-foot lines, which is a lot. And I told you we're producing 1,000 pounds with just 3 lines. But, this could be scaled up. So just for perspective, this is what Mike Dole has come up with. Suppose you wanted to have a 1-acre kelp farm, which really isn't that big. You can see here, he's showing the spacing. And so here, if you had 3 lines, that's where we are to begin with. And he's now instead scaling out the 200-foot lines instead of 100-foot, and you want to space these about 5 foot apart. But if you were to do that, and you had a 1-acre plot, and you got the kinds of yields that we saw last year, you'd end up pulling out per farm somewhere between 32,000 and 72,000 pounds of kelp per acre. And if we scale that on the nitrogen level, this could be almost 200 pounds of nitrogen per acre. And for perspective there, another hat I wear at the university is I'm the director of the New York State Center for Clean Water Technology. We focus a lot on alternative septic systems. Those septic systems denitrify about 12 pounds of nitrogen per year per 2-person household. And so that amount of nitrogen that could be removed by the kelp is up to 18 homes. Now, what's important to recognize here is that nobody's doing 1-acre farms of kelp. So this is really just a thought experiment just to give you the sense that there is the promise there for really mitigating nitrogen. I'm not advocating for this instead of upgrading homes, but it can be yet another what we call tool in the toolbox. Before I get to ocean acidification and climate change, one last topic I want to hit on is harmful algal blooms. If you've ever heard me speak before, this is what I speak about probably the most. These harmful algal blooms can be both toxic and harmful to humans, as well as toxic and harmful to marine life, and in some cases have been responsible for the collapse of some New York fisheries, like the bay scallop. Now, as it turns out, each of these different harmful algal blooms happen at a different time of the year. Some are in spring, some are in summer. So when we think about different seaweeds and the effects they might have on these harmful algal blooms, we need to think about the seasons in which they occur. So I'm not going to talk about it today, but in my lab, we're also working on the aquaculture of Gracilaria, which is a red algae. We've also done work with sea lettuce, ulva, which is often considered a nuisance algae, but we've been able to grow it at high capacity. But sticking with the kelp for a moment, you can see it really overlaps with this species Alexandrium, which frankly to me is the most worrying of the harmful algal blooms. And that's because it makes this compound known as saxitoxin. Saxitoxin is a neurotoxin. Saxitoxin is 1,000 times more potent than cyanide. And it can be a threat to human health because filter feeding bivalves such as mussels, clams, oysters, scallops concentrate, they, by virtue of their name, filter feeding, they're concentrating the plankton as they grow, and they can concentrate both the cells and then the toxin that's within those cells. And this organism is widespread across Long Island. You can see here, any of the sites where you see a red dot is a site where the densities have gotten high enough to make shellfish toxic. And we've had literally more than a dozen shellfish bed closures due to toxic shellfish, and half a dozen sites that have been closed to shellfishing because of blooms of Alexandrium and the presence of saxitoxin in shellfish. And beyond just the human health threat, this is also an animal health threat. In 2015, there was a kill of more than, just say of hundreds of diamondback terrapin turtles in Flanders Bay. At the time, no one, including myself, knew what was going on. It had been suggested that it could be related to an ongoing bloom of Alexandrium and paralytic shellfish poisoning. I dismissed that hypothesis initially, but as we gathered the data, like looking at the toxicity of the mussels in the region, and then looking at using DNA sequencing to look at the gut contents of the turtles, as it turns out, they were eating those mussels, and those mussels got toxic enough to the point where just consumption of one mussel would be enough to kill off these turtles, which are close to being an endangered species in New York. So this is obviously the right type of harmful algal bloom to consider how it might be affected by seaweeds, and I'll give acknowledgement to my graduate student, Peter Silvers, who's looking at that and looking specifically at kelp and a couple of other seaweeds and how they could affect Alexandrium. And so just to give you a sense, if you were to look under the microscope, these are happy and healthy Alexandrium cells. When you expose them to kelp, after just a couple of days, the cells begin to look like this. And what you're looking at are cells that are experiencing what we call chlorosis. So the nice pigment on the inside is shrinking up. And in some case, cell lysis. So you can see the outside of the cell lysing and the inside just spilling out. So you can see it in the microscope. You can also see it in the cell counts. Here's an experiment from the field. We grew Alexandrium where we added nutrients, or alternatively, we added nutrients plus kelp, and it significantly reduced the number of cells. When we looked at what was going on there, just very briefly, when we added the nutrients as expected, the nutrient concentrations went up. But when we added the nutrients and the kelp kept the nutrient levels low, in fact, lower than in the other treatment. So they're actively taking up nutrients in order to combat the harmful algae. A final thing that we did was to look at the ability of the kelp to prevent mussels from becoming toxic. So we did a 4-day experiment where we exposed mussels to toxic Alexandrium cells and the same exact scenario, but also exposed them to kelp. And we saw that the kelp was able to significantly reduce the amount of toxin in the shellfish. It didn't eliminate it entirely, but the actual numbers are important. And that is the FDA closure limit for shellfish is 80 micrograms per 100 grams of shellfish. By adding the kelp, we could keep the mussels below that level. The final thing to talk about is the threat of ocean acidification. I don't need to belabor this point with this group. A lot of people had said, oh, in 2020, everybody stopped driving and the factory shut down. So the CO2 levels must have gotten really low. And so while there was less CO2 produced, the fact of the matter is that was not seen in the global CO2 data set. So here's the data from Scripps Oceanographic. This is known as the Keeling curve. And so these are the direct measurements made by Charles David Keeling since the middle of the 20th century. Dr. Keeling passed away, I believe, sometime in the last decade, but this data set's been kept up by Scripps Oceanographic. And you can see this level, these numbers are only moving in one direction. And frankly, unfortunately, because of the global intensity of prior anthropogenic activities, we could cease combusting all fossil fuels, and these levels will still go up. So that little blip of 2020 is not in the records here. And we know, of course, that not only is the CO2 going up in our atmosphere, it's going up in our oceans, and that's leading to lower levels of pH today than we had in the past. And we know this is really an existential threat to bivalves. Bivalves make calcium carbonate shells. Higher levels of CO2 lead to lower levels of pH, and more importantly for the bivalves, lower levels of carbonate that they need to make their calcium carbonate shells. And so about a decade ago, my lab published on the threat of ocean acidification to some of our regional bivalves. These are larval bay scallops and hard clams. In this case, we compared what was then the ambient levels of CO2. So it really dates, we're really dated here. We're now at 417. This experiment was a decade ago when we were only at 390. So the one relevant thing here is that if you look, we use 250 as a pre-industrial level of CO2. And the first important finding here is that compared to pre-industrial levels of CO2, the survival of these bivalve larvae at today's levels of CO2 were statistically lower. And what that's telling us is that today's ocean acidification is already affecting bivalves. We don't need to think about the future. It's already here. And you can see as things progress, things don't get any better. We also took microscopic images of these bivalves. You can see them here, both hard clams and bay scallops. And you can see as you ramp up the CO2 levels, these individuals get smaller and smaller. And this image, I'm proud to say, was actually used by the Obama White House when they issued their report called The Challenge of Ocean Acidification in 2014. This was figure 3 of 4 figures within that document. We also looked at how thin these bivalves became, and that's shown here. And you can see the shells went from being extremely thick to quite thin. And so the question is, can seaweeds combat this? My lab's actually already proven that they can. So this is a paper we published a few years back. It's available free online. Anybody can download it. And essentially what it showed was the ability of, in this case, for this first set of experiments, we just used ova and to understand how it might affect the growth of, you can see 4 different bivalves here we studied: clams, lobsters, clams, oysters, scallops, and mussels. And what we saw is that when we grew oysters, for example, with ova, there was not a big effect. When we added CO2 to an environmentally realistic level, growth rates plummeted to near 0. But when we added in the seaweeds, we could significantly increase those growth rates. Couldn't fully rescue them, but significantly increase the rate at which the oysters could grow. And we know this was due to the chemistry. And just as an example, here's an experiment that we did just earlier this month, in fact, since it is kelp season, where we took acidified water and we either added living and growing kelp to it or not. And we divided that up, and you can see the pH scale here, and you can see how in just a matter of days from February 26th to just, well, I guess less than a week later or a week or so later, the pH went from a very low and damaging level to actually almost, not almost, a basified level. So actually much higher than you would see. So this is a very strong anti-acidification effect. And going back to that graduate student, Peter Silvers, and his work, this is his data on 3 different types of seaweeds, including kelp, essentially just showing that, you know, if he did nothing, these dots here on the, where he added no macroalgae, the pH was always around 8. And you can see that the seaweeds all drove up that pH. So therefore, if we look at all of these effects, and I can see I have a little bit of a cutoff here, that's supposed to say protecting shellfish aquaculture with kelp, the halo effect. And so that's the one important thing I want to emphasize here, that the effect word got cut off. But, you know, seaweeds are not going to, at a local level at least, be the only tool in the toolbox for combating climate change, obviously. But because of this very concentrated, localized effect, I think they're an incredibly useful tool for protecting shellfish aquaculture. Very last thing I want to leave you with is just some work we're doing on using these seaweeds to convert them into fertilizer. I always have this vision, we live on an island, and every spring, as we get towards the growing season, I have this vision of all these 18-wheelers driving over the bridges onto Long Island, be it the Throgs Neck or the Whitestone or the Verrazano Bridge, but bringing all this fertilizer onto Long Island. And wouldn't it be great if we could break that cycle and have that fertilizer come from somewhere else? And we've made some progress on this at the university. If you look here, I've got 3 different types of fertilizer here, and they have the nitrogen and phosphorus content. And right now I've hidden the labels here. One of these 3 is Miracle Grow. The other 2 is based on seaweeds. So by eye, can you tell which is the Miracle Grow and which is the seaweeds? This is the nitrogen content that we're able to generate per liter of solution from a liquid Miracle Grow and from 2 other types of seaweeds. So this is the game show part of the seminar. Can you guess which is the Miracle Grow? And now you can tell me if you guessed correctly. So the bottom line is we can make a solution far more potent than Miracle Grow out of seaweeds. And so this is, you can see what we can now generate out of kelp. And we also, work with summer seaweeds, which actually accumulate a lot more nitrogen and phosphorus, or actually even more potent. We've also used these on different crops. This is my son, now 12. I believe in this picture he might have been 10. But again, we can play the guessing game. Can you guess which set of eggplants received the seaweed fertilizer? Probably can. So we were able to demonstrate that the seaweed fertilizers are able to significantly enhance the weight of eggplant yields compared to not using any fertilizer. We had similar results with bell peppers, both with regards to weight and number of fruits. And finally, this data is a little bit more complex. In this case, our positive control was Miracle Grow. Our negative control was doing nothing. This is for marigolds. And so you can see Miracle Grow does the job for these flowers. If we use just a kelp-based fertilizer, well, it's certainly better than nothing, not quite the Miracle Grow. If we use the summer seaweeds, again, significantly better and approaching the Miracle Grow, but actually when we combine them, we have the best yields of all. So we are seeing the potential for these seaweeds to turn into fertilizer to make a sustainable fertilizer. So with that, I'm done. So I've shown you that seaweeds can improve water quality by removing CO2 and nitrogen, secreting oxygen and secreting allelopathic compounds to mitigate harmful algal blooms. And I've shown you some of these harmful algal blooms are lysed, and the toxicity can be mitigated, and the ocean acidification can be mitigated by kelp. We still need research, however, to really hone in on the exact scale that's needed to have these environmental effects. The good news is, like I said, if your target is simply a shellfish farm, you just need that halo effect. So with that, I'm done. I hope I didn't go too long, and I'm happy to discuss things or take questions now or later.
No,
Great. That was spectacular, Chris. Thanks so much. It's great to see how the kelp is interacting in the real world environments and all of the analytics that you've applied to it with chemistry and so forth. We're going to do questions after we've had the 3 speakers get a chance to address the audience. With that, let me introduce our second speaker. Sean Barrett is a co-founder of Dr. Dish in Montauk. He is one of the co-founders of the first community-supported fisheries in New York State. Now he has 45 fishermen, and that has been connected to chefs and individuals who join the local purchase of seafood in advance. Sean is also on the board of Green Wave, which is the Connecticut not-for-profit that has created the 3D restorative ocean farming model that Chris just referred to. and they have plans to train 5,000 more ocean farmers nationally. They've recently launched a campaign called Eat More Kelp. And I believe, Mark, you're going to run a short video that comes from Sean. Okay, great. So we're going to just proceed.